This is the first section of a 4-section module on pressure safety high and pressure safety low shutdown test procedures for pressurized vessels. The pressure safety's function test is one that you should understand and be able to perform after completion of this module. The purpose of this test is to determine at what pressure the pressure safety high and pressure safety low sensors trip and sound an alarm. These pressure readings must occur within the proper range for the vessel being tested. If out of range, the sensor must be adjusted to perform correctly. To conduct the test, the vessel's sensing line to the pressure safety pilots or sensors is switched into test mode. This isolates the vessel from the sensors and allows the connection to the test equipment. The test rig consists of a test manifold and a bottle of pressurized nitrogen. Using the test rig, we'll be able to increase and decrease the pressure to the sensors, allowing us to determine the pressure at which each sensor trips and resets. Now let's go through the key steps which make up the pressure safety high, pressure safety low test. First, check previous pressure charts on the vessel to be tested to see if they're current with present operating parameters. For example, new wells coming online, production falling off, or pipeline pressure changes are just a few of the conditions that can change present operating parameters. If the previous pressure settings are found to be inadequate for present conditions, then new pressure charts will be required in order to establish the needed pressure safety high, pressure safety low sensor or pilot settings. If the charts prove to be current, review any problems or special items that have occurred on previous tests. Note the previous pressures used to test the pressure safeties. Be sure to meet with all personnel involved in the test so each person knows his or her responsibilities. This meeting should include the control room operator and/or the person in charge. Next, all personnel should be informed that you're conducting a pressure safety high, pressure safety low test and that alarms will be sounded. The person stationed in the control room should acknowledge alarms and bypass the safety shutdown system being tested. Each time equipment is bypassed, the time and date must be recorded in the bypass log. Next, ask the person assisting you in the control room to put the system into bypass. Wait for confirmation before proceeding. At this point, it's time to connect the test equipment to the test port. Now, with the test operate valve still in the operate position, connect the hose on the test rig to the test port. Close the pressure bleed-off needle valve, close the speed control needle valve, and open your bottle outlet valve. Open the pressure speed control needle valve, then slowly run in the pressure regulator adjustment and start the nitrogen pressuring up the test manifold and flexible hose. As long as the test operate valve is in the operate position, pressure from the test equipment will not enter the device being tested. Keep pressuring up slowly until you reach the point where the pressure leaving the regulator is slightly higher than the maximum needed to test pressure safety high. In this example, we have a pressure safety high setting of 1000 psi, so 1100 psi is a good setting. After the regulator is adjusted, close the speed control needle valve and slowly open the pressure bleed-off needle valve enough to drop down to the current operating pressure of the unit. Once you have approximately the same pressure on the test gauge as the current operating pressure of the unit, move the test operate valve from the operate position to the test position. This procedure will allow the switch to be made without pressure shocking the system. With the test operate valve in the test position, pressure from the vessel to the sensors is blocked. Now slowly pressure up using the speed control needle valve toward the pressure safety high set point. When you get close to the setting, say within 10 or 15 pounds on a 1,000 pound setting, slow down considerably. Now your flow should be reduced to a maximum of 2 or 3 pounds per second. In some cases, you may even want to slow down to 1 pound per second. This reduced rate is important due to the slow reaction of some sensors or pilots. If the rate of pressure change is too fast, you'll get a reading that is artificially high. When you trip the pressure safety high sensor, you'll hear the alarm, and the person stationed in the control room should acknowledge the alarm and notify you on which device the alarm sounded. Note the pressure reading when the alarm trips. Now you should close the pressure speed control needle valve and then lower the pressure using the pressure bleed-off needle valve to reach the pressure safety high reset point. To get an accurate reading, it's important for the person in the control room to notify you immediately when the sensor resets on the device you're testing. Close the bleed-off needle valve and note the pressure. Prompt notification of reset is essential because this is how you determine how much deadband the sensor has. We'll cover deadband later in this module. When testing pressure safety sensors other than well-control panel mounted pressure safety highs and pressure safety lows, you have no way to know when the pilot actually reached reset pressure. The person stationed in the control room must notify you of the sensor reset when the alarm light clears. The difference between the pressure safety high trip reading and the reset reading is called deadband. The amount of deadband gives us some insight into the condition of the sensor. Depending on the device and operating pressure range, it should only be around 3% of the actual adjusted range of the sensor. For example, in a device ranging from 0 to 1000 psi, the deadband should be about 30 psi. If the deadband has deteriorated to about 7% or 70 psi, it's time to pull the sensor for maintenance. Due to the mechanical nature of their operation, stick pilot sensors typically require more maintenance than other sensors in order to stay within the manufacturer's recommended limits for deadband. If you have to make a setting change on a stick pilot sensor to make it actuate at a higher pressure, you must rotate the adjusting screw clockwise to compress the spring, thus increasing its preload tension. This will increase the pressure needed to overcome the spring pressure and actuate the alarm. Decreasing the preload on the spring lowers the amount of pressure needed to actuate the stick pilot sensor, causing it to trip at a lower pressure. If you've tested pressure safety high and it's within the manufacturer's deadband limit, you can move on to test the pressure safety low sensor. First, with the speed control needle valve closed, slowly vent the pressure by opening the pressure bleed-off needle valve. Again, as we get near the actuation point for pressure safety low, slow down to a couple of pounds per second. When the actuation point is reached, you'll hear the alarm. The person in the control room should acknowledge the alarm and notify you of a pressure safety low on the equipment you're testing. Close the pressure bleed-off needle valve and make a note of the reading. Now let's see where the pressure safety low resets. Slowly open the speed control needle valve to start increasing the pressure. When the unit resets, the alarm will clear and the control room should immediately announce that the alarm has cleared. If the deadband falls within an acceptable range, you can prepare to disconnect the test rig from the vessel. If not, repeat the test as necessary, checking the sensor's trip point, reset point, and deadband. Make adjustment as needed to get the unit within specification. Using the speed control needle valve, increase the test manifold's pressure to match the current operating pressure of the vessel. Now it's time to return the unit to operation. When the two pressures match, move the test operate valve back to the operate position. Now, close the nitrogen bottle outlet valve, open the bleed-off needle valve, and allow the system to blow down completely of any pressure. Rotate the pressure regulator adjustment bar counterclockwise to a minimum pressure setting. Then disconnect the hose from the test panel. Now the test manifold may be removed from the nitrogen bottle. The cap should be replaced and the bottle properly stored. Inform the control room that the unit is back in operation. The control room operator should then take the unit out of bypass and log the date and time. Any problems encountered should be noted and the conclusion of the test announced to all platform personnel. In this section, we'll look at the key steps involved in conducting this test using a hydraulic hand pump. Our test is run by switching the sensor line from the vessel into test and connecting the hose from the hydraulic pump to the test port. Using the hand pump and test manifold, we'll be able to increase and decrease the pressure going to the sensors, allowing us to determine the pressures at which each sensor trips and resets. This also provides a check of the alarms and associated circuits. Let's look at the test equipment needed for this test. First, we have a hydraulic pump with a vent pump valve. The pump is connected to a test manifold. The test manifold consists of an accurate test gauge and a pressure bleed-off needle valve. The test gauge should be of the proper range and used only as a test gauge. It should be of test quality and accurate to not less than plus or minus 0.5% of the full scale. Lastly, a quick connector is attached to a pressure hose. As with all pressure systems, make sure that each component is rated higher than the pressures you'll need to perform the test. Now let's go through the key steps that make up the pressure safety high, pressure safety low test when using a hydraulic hand pump. As we covered in section 1, to get started we should check the previous pressure charts to see if they're current with the present operating parameters. If previous pressure settings are found to be inadequate for present conditions, then new pressure charts will be required to establish the needed pressure safety high and pressure safety low sensor settings. If you have any questions regarding the status of the pressure charts, contact your supervisor. If the charts prove to be current, then review any problems that may have occurred on previous tests. Note the most recent trip and reset pressures used on the vessel to be tested. Before beginning the test, inform all personnel on the platform that you're conducting a test and that alarms will be sounded. Someone should be stationed in the control room to acknowledge alarms and bypass the safety shutdown system. Inform the person in the control room that you're about to begin the test and wait for confirmation that the system has been put into bypass. Each time equipment is bypassed, the time and date must be noted in the bypass log. Before beginning, make sure the pressure bleed-off needle valve is in the open position. This assures there's no pressure in the test manifold. Now connect the high pressure hose from the hydraulic pump to the test port on the panel. Set the vent pump valve on the hand pump to pump action. Close the pressure bleed-off needle valve. With the normal test valve still in the normal position, bring the test pressure up as close as possible to the operating pressure of the vessel being tested. With the two pressures approximately the same, turn the normal test valve to the test position. Now let's run up the pressure safety high set point. Slowly pump up the pressure on the hydraulic pump while watching the test gauge. When the pressure safety high sensor or pilot trips, you should hear the alarm. The control room should acknowledge the alarm and notify you that it is tripped on the device you're testing. Note the reading. Then slowly reduce the pressure using the pressure bleed-off needle valve. Spent hydraulic fluid should be drained into an appropriate container. As you pass the reset pressure, the device should reset and clear the alarm. The control room should notify you immediately when this happens. Note the reading at reset. As we covered in the first section, the difference between the trip and reset pressures is called deadband. Depending on type of device and the pressure range of the vessel, this value should be approximately 3% or less of the operating range. This gives you some insight into the condition of the sensors. Typically, the smaller the deadband, the better the condition of the sensors. If the pressure safety high trip and reset points are within the 3% range, then continue on to check the pressure safety low set point. If they're not, then adjust the sensor and run the test again. If the deadband cannot be adjusted to within 3%, it's time to rebuild or replace the sensor. Continue to reduce pressure until the pressure safety low sensor trips. At this point, the control room should acknowledge the alarm and notify you of a pressure safety low alarm. Note the pressure reading when the alarm triggered. Close the pressure bleed-off valve and slowly begin pumping in more pressure until the sensor resets. The control room should immediately inform you when the alarm clears. Note the pressure at reset. If pressure safety low sensors fail to trip or reset at the proper pressure, they should be retested before any adjustments are made. If everything is within spec, continue to increase the test pressure up to the current operating pressure of the vessel being tested. When the current operating pressure is reached, move the test operate valve back to the operate position. Next, slowly open the pressure bleed-off needle valve, venting the manifold of any pressure. Again, hydraulic fluid should be properly contained. Now, switch the vent pump valve on the hand pump to vent and disconnect from the test panel. Inform the control room that the unit is back in operation and can be taken out of bypass. The control room operator should log the time and date when the unit is taken out of bypass. In Section 3, we'll look at some potential problems you may have to troubleshoot during a test. In this section, we'll look at some potential problems you may encounter during the test when using the nitrogen bottle or the hydraulic hand pump. To get started, let's look at the adjustment procedures for two of the most common pressure safety high, pressure safety low sensors: stick pilot sensors and nozzle flapper board-on tube pilots. If the trip point on a stick pilot sensor is not at the proper pressure, then adjust the trip point by first backing off the locking ring on the spring adjusting cap. To increase the pressure at which the sensor trips, rotate the adjusting screw clockwise to tighten the spring. Conversely, to lower the sensor's trip point pressure, rotate the adjusting screw counterclockwise to loosen the spring. Make adjustments in small increments and check the new trip point after each adjustment. Pressure safety trip points are changed on nozzle flapper pilots by loosening the locking disc and turning the adjusting screw clockwise to increase the trip point pressure setting, or counterclockwise to decrease the trip point pressure setting. While nozzle flapper board-on tube pilots are sensitive to overpressuring, stick pilots are prone to an increasing deadband as time goes by due to several things: the deterioration of O-rings exposed to hydrocarbons, mineral scaling due to the nature of the liquid or gas used in the process, and the deterioration of lubricants as well as other moving parts. Excessive deadband can become a real problem when you're coming up from a shutdown condition and the pressure won't get high enough or low enough to reset the sensors. If you experience excessive deadband during a test, notify instrument and electrical personnel or your supervisor immediately. One of the first key steps during the pressure safeties test is to check the vessel's previous pressure charts. If you need a new chart for a particular process, log the pressure for 24 hours to establish the normal operating pressure. Then set your new pressure safety high at the new operating pressure plus 15%. Pressure safety low should be set at the new operating pressure minus 15%. When connecting the test manifold to the test panel, if a quick connector will not plug into the test port, you probably have pressure trapped in the line between the test port and the test operate valve. This pressure must be bled off to allow the connector to slide into place. There's usually a bleed-off valve on the test panel to vent the test port. Test port bleed-off valves should be switched into the test position when conducting the pressure safeties test. If the test gauge fails to pressure up or acts sluggish, several things could be at fault. The upstream speed control needle valve may be plugged with debris. A test gauge quick connect may not be properly coupled. The test gauge filter or inlet line may be plugged. Before you attempt to work on the test manifold, make sure the entire system is bled down and pressure free. During the test, if the sensor trips but the alarm fails to sound, the problem could be a failure somewhere along the circuit path. However, keep in mind that on some platforms, the control room operator must reset the alarm after acknowledging it. This is usually necessary when checking the same device more than one time. Check to make sure the control room operator has pressed reset, then run the test again. If it still fails to sound an alarm, then notify instrument and electrical repair personnel immediately. If the sensor or pilot does not trip at the desired pressure actuation point, run the test again before making any adjustments. Quite often, the sensors may be sticky and may read differently the second time after being broken free. If after several attempts the sensor still will not perform consistently, then repair or replacement is necessary. If you conduct a test using a hydraulic hand pump, you may be tempted to pressure up and down using the vent pump valve and skipping the use of the pressure bleed-off needle valve. Now, even though this would conserve pump fluid and save the trouble of disposing of the used hydraulic fluid, this is not good operating practice. The pressure bleed-off needle valve allows us to dump the fluid and pressure before it gets back into the pump body. This is important for several reasons. First, it reduces the possibility of trash or debris in the process fluid from flowing back into the pump. Just a small amount of foreign material or debris in the hand pump valve action can cause the pump not to work, resulting in lost time spent cleaning or rebuilding the pump. Second, dumping the hydraulic fluid minimizes the possibility of a pressure change rapid enough to overpressure the pump's oil reserve case and crack the pump housing and spray its contents on any bystanders. Third, the vent pump valve is not designed to adequately vent the volume of fluid and pressure required. To be safe and efficient, attach a flexible hose or tubing to the pressure bleed-off needle valve to lower the pressure. That way, the used hydraulic fluid can be drained into a suitable container or bucket. A full nitrogen bottle contains approximately 2,000 psi, so take care when connecting or disconnecting hoses or lines. Keep all fittings clean and free from dirt. Make sure connections are complete. A fitting or hose propelled by high pressure can do a lot of damage in a hurry. When you're opening a closed valve, be sure to open it just enough to allow pressure to flow. Allow time for pressure equalization to take place before continuing. Never open and close valves rapidly. Rapid changes in pressure can pressure shock the system, damaging O-rings and gauges. You've successfully completed this section.